Welcome to the Deep Dive. Today we're tackling a really important topic, something that's definitely changing education as we speak. Explainable AI, or XAI.
That's right. And we've really been immersing ourselves in this fantastic report. It's from the European Digital Education Hub Squad, focusing specifically on explainable AI in education.
The European Digital Education Hub. It's a great online community, isn't it?
Yeah.
For educators across Europe, all sharing insights on digital learning.
Absolutely. And this report we're digging into, it's a real collaborative effort. People like Francisco Bellas, Jeroen Uj, Leslie Rodek, many others contributed.
It really shows, the collective brain power being focused on this area.
Definitely. So our goal today, pretty straightforward, really. Cut through all this great information and figure out why explainability is becoming so crucial for AI in education.
And what that means for everyone involved,
Oh,
right?
yeah.
Especially, for you, the learner.
Yeah.
Okay, so let's maybe start with this whole idea of explainable. I mean, think about the software you use daily, like a photo editor or your phone suggesting emojis.
Right. You don't usually ask why it suggested that particular filter or emoji, do you?
No, not really. But when we talk about AI, and especially AI in something as vital as education, suddenly knowing the why feels essential.
And that's because the nature of the tasks is changing. Old software, it just followed instructions, but AI is taking on tasks humans used to handle.
Dealing with complex data.
Huge amounts of complex data, but it lacks our kind of reasoning or common sense, and crucially, its outputs aren't always accurate.
Which is a bit scary when you think about it impacting learning. So if an AI is guiding a student or maybe even grading their work.
You really need to understand its thinking process. You need that insight.
Which brings us neatly to the first big question. What exactly is explainable AI?
Okay, so at its heart, XAI is about understanding why an AI system does what it does, why it behaves a certain way, why it gives a specific interpretation or makes a particular recommendation.
It's like lifting the lid, peering inside the box.
Pretty much shining a light on those often complex internal workings.
And this isn't just a nice-to-have feature, is it? It seems fundamental if we want to trust these systems.
It's absolutely fundamental. It links directly to the whole concept of trustworthy AI. Remember the European Commission's ethics guidelines?
Yeah, they emphasized transparency, didn't they?
Exactly. Transparency, understanding how a system works, was flagged as a key requirement. If we're going to trust AI, especially in education, we need to grasp how it reaches its conclusions. That's where XAI comes in.
Okay, so maybe the specific term explainable AI isn't in every single law yet.
That's true. But regulations like the EU AI Act, for instance, they do talk about very closely related, very important concepts. Things like ensuring human oversight.
Keeping humans in control.
Right. And good data governance, security, transparency, and critically, the right for individuals to understand automated decisions made about them.
Which loops back to that question. Why the sudden need? We didn't demand this from, say, spell checkers back in the day.
Well, again, it's about the tasks AI is doing now. It's taking on roles with real human impact, making decisions that affect learning paths, opportunities. Human agency is key here.
And the outputs are complex, sometimes even wrong, as you said.
Precisely. If we can't understand the why, we risk giving too much authority to systems we don't fully grasp. We lose the ability to question them effectively or, correct them when they go wrong.
Okay, got it. So we know what XAI is, why it's crucial now. Let's dig a bit into the technical side. The report mentions two main approaches to building AI, knowledge-based and data-driven. What's the core difference there?
Think of it like this. Knowledge-based AI is like giving the computer a very detailed rulebook, explicit instructions, like those older intelligent tutoring systems, maybe?
Right, the ones that followed clear steps.
Exactly. They might have a rule like, if student answers question 5 incorrectly, then show explanation B and provide problem 5A. Explaining that is straightforward. You just follow the programmed logic.
Like reading the rule book. Maybe a student sees a dashboard showing progress based on which rules triggered.
Precisely. Like the examples Musavina Sab and others described, simple rule-based reasoning, visual dashboards. Quite transparent, really.
Okay, that sounds graspable, but then there's data-driven AI. That sounds different.
It is, and explaining the why here is, well, generally much harder. Data-driven AI Think machine learning, neural networks. It learns by finding patterns in massive amounts of data.
So no explicit rule book.
Not in the same way. Instead of rules, its knowledge is embedded in like a complex web of connections and numerical parameters that it figures out from the data
A
itself.
tangled web. Okay, so explaining that is trickier.
Much trickier. The report uses a great analogy: an AI assistant helping a mechanic diagnose a car problem. A knowledge-based system, maybe using case-based reasoning, would compare the current symptoms to a database of past cases. The explanation might be, this knocking sound plus that flashing light matched case hashtag 123, which was a faulty fuel pump.
Clear enough? And the data-driven approach.
A data-driven AI, maybe a neural network, takes the symptoms, processes them through its complex layers, and might output 85% probability of fault at fuel pump.
But why 85%?
Exactly. Explaining that involves the intricate interplay of all those internal connections and numbers based on all the repair data it learned from. It's not a simple rule lookup. Table 1 in the report really drives home this difference in explanation complexity.
So it sounds like there's a trade-off. The systems that are easier to explain might not be the best performers on really complex tasks.
That's often the case, yeah. Simpler models, like decision trees where you can literally trace the decision path, are inherently more interpretable. We call them white box models sometimes.
White box, okay.
But for really complex challenges, data-driven models, the black box ones like neural networks, often achieve higher accuracy or performance.
But researchers are working on making those black boxes more understandable, right?
Absolutely. There's a huge amount of research, like Benatot and colleagues mentioned, focused on developing techniques to peer inside those complex models and make them more explainable. We shouldn't just write them off.
That's good to hear. Okay, so building on this, the report introduces 4 core concepts underpinning XAI: transparency, interpretability, explainability, and understandability. Let's break those down, starting with transparency.
Transparency is essentially about openness and access to information. It means sharing details about the data used, the model itself, the processes involved in building and running it, and the final outcome.
So information is available.
Right. The EU AI Act's Recital 27 touches on this too, needing traceability, appropriate explanation, letting users know they're dealing with an AI. It's about making the system scrutable.
So the onus is really on the developers to provide this information.
Largely, yes. The report outlines 5 key aspects developers should consider for transparency: the data, origin, quality prep; the model, algorithms choices; the process, design, testing; the outcome, results, confidence; and crucially for education, justifying the choices in a way educators can actually use.
Makes sense. Okay, next, interpretability.
Interpretability is about how easily a human can inherently understand how a model works or makes decisions just by looking at its structure or logic.
So it's a property of the model itself.
Exactly.
Yeah.
We talked about those white box models like decision trees. They are inherently interpretable because their logic is relatively simple and visible. Then you have the more complex, opaque models like neural networks, where the internal workings are much harder for a human to intuitively grasp.
Okay, so interpretability is about the potential to understand the model's mechanics. How does explainability differ? They sound similar.
They're related but distinct. Explainability is more active. It's about the system providing clear, coherent justifications for specific predictions or decisions it makes.
So interpretability is passive, the model is understandable, explainability is active, the system gives an explanation.
Precisely. It answers the question, why did you do that in this specific instance? In a way humans can comprehend. It's about clarifying function to enable understanding.
Got it. And the last one, understandability.
Understandability brings it back to the human receiving the explanation. It's about how why that explanation actually makes sense to them, given their own knowledge and context.
So an explanation could be technically correct and provided, explainability, but if the user doesn't get it.
It's not truly understandable. It fails. It has to resonate with the target audience's knowledge level. It's very human-centric. An explanation filled with jargon might be accurate, but useless if the teacher or student can't make sense of it.
So all 4 need to work together for XAI to be effective. Transparency makes information available, interpretability relates to the model's inherent clarity, explainability is the act of providing reasons, and understandability is whether the person actually grasps it.
Exactly. And Table 2 in the report revisits that car mechanic AI to show how a developer could integrate all 4 to build trust. It connects the dots nicely.
Okay, building on that, the report also lists key features of good explanations. What makes an explanation effective? Table 3 covers this.
Right. It breaks down the characteristics, things like justification. The explanation needs to give reasons, evidence for the AI's conclusion.
Not just what, but why.
Precisely. Then there's tier detail, recognizing that different people need different levels of depth. A quick summary for a student, perhaps, with an option for the teacher to dig deeper.
Customizable explanations.
Kind of. And relevance, of course. The explanation has to be meaningful in context. If an AI tutor suggests more practice, the explanation should relate directly to the student's recent performance on specific skills.
Makes sense. Table 3 also mentions specificity, things like explaining the model's process, its limitations, traceability, auditability. Sounds important for accountability.
Hugely important. Specificity about the process gives insight into how the AI used the data and its model. Acknowledging limitations, saying, I'm only 80% sure, or my data on this topic is limited, builds trust and manages expectations.
Honesty about uncertainty.
Yes. And traceability and auditability mean you could figure out who's responsible and review the decision-making steps if needed.
And the final point in the table is consistency.
Crucial for reliability. Explanations should be stable. Similar inputs should lead to logically similar explanations, and different levels of explanations, summary versus deep dive, shouldn't contradict each other.
So a good explanation is justified, tailored, relevant, specific, honest about limits, traceable, and consistent. That's quite a list.
It is, but it's what's needed for genuine trust and utility.
Now, the report also talks about different perspectives the actors involved in XAI. Who are we talking about here?
Broadly, three main groups. The developers creating the AI system.
The tech folks.
Right. Then policymakers setting the rules and guidelines. And finally, the end users, the people actually interacting with the AI.
And end users can be professionals using it for work or just the general public, right?
Exactly. And all these groups have a role. Developers build in explainability, policymakers create the environment for it, and users, by demanding and expecting explanations, drive its adoption.
And in education, the key end users are learners, educators, administrators.
Precisely. And the impact of XAI there is huge. The report highlights two main benefits: building capacity, helping everyone understand and engage critically with AI.
AI literacy, essentially.
Yes, AI literacy. And secondly, ensuring the AI tools used are ethical, reliable, and fair.
So for learners specifically, how does XAI help? You mentioned agency earlier.
It helps prevent what some researchers call de-skilling. If students just get answers from an AI without understanding why, they don't learn as deeply. XAI, by explaining the reasoning, can help them take ownership, understand the process, and think critically.
So it keeps the learner active.
Exactly, which is why educational authorities need to prioritize learner understandability when choosing AI tools.
The report also lists some key principles for implementing XAI in education. Can you summarize those?
Sure. It stresses promoting metacognition and agency, helping students think about their own learning, ensuring legal compliance, especially with data privacy like GDPR.
Handling messy educational data effectively.
Right. Education data is notoriously noisy, and making sure the outputs, the explanations, are clear, useful, and relevant to actual educational goals.
Okay, now, Table 4 looks really useful. It breaks down explainability into different dimensions. Scope, depth, alternatives, flow. Can you unpack those?
Yeah, this is a helpful framework. First, scope. Is the explanation global or local?
Global meaning.
Big picture. Explaining the overall logic or behavior of the AI system. A school principal might want a global explanation to assess if a tool aligns with school policy.
And local.
Specific instance. Explaining why the AI made one particular decision or prediction. Like a teacher wanting to know why the student got this specific feedback.
Got it. Global versus local. Next is depth.
This is about how much detail is provided. Comprehensive explanations give the full story, maybe for a detailed audit. Selective explanations offer a summary, perhaps for quick feedback to a student or parent.
Okay, then alternatives. Contrastive versus non-contrastive.
Right, contrastive explanations compare the actual outcome to other possibilities. Why did student A get a higher grade than student B? The explanation would highlight the key differences the AI focused on.
And non-contrastive.
Just explains the outcome without comparing. Here's why the system recommended these learning activities for you, focusing solely on the factors for that specific recommendation.
Makes sense. And the last dimension is flow. Conditional versus correlational.
Conditional explanations usually show a direct cause-effect, often using if-then logic. If you spend less than 15 minutes, then the system recommends reviewing. Clear rule.
And correlational.
Shows relationships or trends in the data. Students who consistently use the practice module tend to show higher scores. It shows a link, a correlation, but not necessarily a direct program rule causing it.
Okay, that breakdown in Table 4 scope, depth, alternatives, flow gives a really structured way to think about the kind of explanation needed.
Exactly. Different situations, different users need different types of explanation.
Now, the report provides some helpful backgrounders: educational, legal, technical. Let's touch on the educational one first. Key takeaways for using XAI in education.
The educational primer really hammers home transparency and interpretability for building trust. It emphasizes that explanations need to be relevant and actionable.
And it mentions responsibilities.
Yes, developers need to make algorithms transparent. Educators need skills to interpret results and validate them. Operators, like schools, need to monitor performance and compliance.
What about fairness and bias?
Crucial point. It discusses using explanations to check for fairness, comparing outcomes for different student groups, and how different explanation types counterfactual, what if, feature-based, which factors mattered, procedural, step by step, can help uncover potential biases, plus the importance of transparency around data usage and GDPR.
Okay. Moving to the legal primer. This gets into the EU AI Act. What are the key legal points?
It introduces the AI Act's risk-based approach. Some AI is prohibited, like social scoring, then high risk, minimal, and low risk.
And a lot of educational AI might fall into high risk.
Quite possibly, yes, especially AI used for things like determining access to education or vocational training or evaluating learning outcomes. Those are listed in Annex 3 and generally considered high risk under Article 6.2.
What does high risk mean in practice?
It triggers significant obligations for both the AI providers, developers, and the deployers, schools, universities. Things like robust risk management, high-quality data, clear documentation, record-keeping, accuracy, security.
And transparency and human oversight.
Absolutely central. These obligations, especially for Annex 3 systems, kick in properly around August 2026. Deployers need to use the AI as intended, monitor it, and ensure qualified humans are overseeing it.
Human oversight seems critical. How does that work?
It varies. Sometimes it's human-in-the-loop, HITL, where a person approves every key decision. Other times it might be human-on-the-loop, reviewing periodically, or human-in-command, able to intervene anytime. The level depends on the risk and context. You need the right expert overseeing it, too.
What about sensitive things like facial recognition in schools?
Generally high risk, especially for monitoring or tracking. Using it just for verification, like logging in, might be lower risk, but still needs transparency and GDPR compliance. Any high-risk use requires informing people, Article 53, GDPR adherence, opt-outs where possible, and crucially, a fundamental rights impact assessment, FRIA, under Article 27 before deployment. Explainability here ensures data is used as intended.
And for lower risk AI, like chatbots or content generators.
Even then, Article 50 requires transparency. Users must be informed they're interacting with AI or viewing AI-generated content, like deepfakes, which need labeling. Plus, Article 86 gives a right to explanation for certain AI-driven decisions by deployers. This complements GDPR's rights, Articles 12-15, regarding automated decisions. Table 5 in the report maps these obligations well.
Wow, okay, a complex legal landscape. And briefly, the technical primer.
It highlights that educational AI often involves multiple models working together, so explainability needs to be comprehensive and tailored. It also notes that while we often focus on explaining the model itself, understanding the whole development environment design choices, data collection assumptions is also vital.
Like the eye tracking example, understanding how gaze connects to attention.
Exactly, and it reminds us of the two main XAI method types: anti-hoc, interpretable by design like rule-based systems or linear regression, and post-hoc, techniques applied after training to explain black boxes like feature importance or visualizations like saliency maps.
Anti-hoc built in, post-hoc applied later. Got it. Okay, let's make this concrete. The report uses 3 use cases. First, an AI tool flags Amyul's work as potentially AI-generated. What are the XAI issues?
Well, educationally, the big issue is accuracy and fairness. These detection tools are probabilistic, not definitive. They can make errors, especially with diverse writing styles. Teachers need AI literacy to use these tools cautiously as part of a human-centered assessment, not as the final word.
Legally.
Likely high risk under the AI Act, Article 6.2 and X3. That means a FRIA is probably needed. Transparency obligations, Article 13, apply. The provider must be clear about the tool's capabilities and limits. Human oversight, Article 14, is essential. Teachers need training and the ability to override. GDPR concerns around fairness and Emil's right to explanation and challenge are also key.
In technical.
If it was a white box model, explaining would be easier, but often they're black boxes. Table 7 clarifies the error types. False positives, like Emil's case, wrongly accusing him, are the most critical error here. We need good performance metrics, but also understandable explanations for the teacher, maybe highlighting flag text sections. The challenge is the black box nature and the resource costs of effective human review.
So recommendations.
Transparency about tool use, validation for diverse students, mandatory human oversight, conducting FRIAs and DPIAs, data protection impact assessments, training educators on risks, clear appeal mechanisms, and demanding interpretable explanations from providers. An interdisciplinary approach is needed.
Okay, use case 2. Julia uses an AI-powered digital textbook adapting to her dyslexia.
Educationally, transparency and human oversight are paramount. The teacher needs to see how it's adapting and be able to intervene. Inclusive AI frameworks and robust data protection policies are vital.
Legally.
Again, likely high risk, Article 6.2, Annex 3, requires a FRIA. Provider obligations include understandable explanations, Article 13, clear instructions, proper data governance, Article 10, and design for human oversight, Article 14. GDPR is huge here due to sensitive health-related data minimization, purpose limitation, consent, rights to access, correct, delete, DPIA needed. Maybe even DSA rules on transparency and protecting minors apply.
And technically, XAI's role.
XAI is key for transparency and trust. The dashboard design explaining progress is critical. Protecting sensitive data, Data Act relevance, is crucial. Explanations of why adaptations are made are needed to avoid misinterpretations of Julie's needs. Both global overall factors and local specific adaptations explanations are useful. HITL is vital.
Challenges and recommendations here.
Challenges include legal compliance, transparency, explainability, privacy oversight, robust data governance, avoiding bias in adaptation, clear consent, and preventing harm. Recommendations echo the first case. Transparency, validation, human oversight, impact assessments, educator training, assessing effectiveness, embedding oversight by design, tools for teacher intervention, clear explanations for all, and interdisciplinary work.
Final use case. An AI essay grader consistently gives lower scores to students from diverse linguistic backgrounds. Obvious bias issue.
Yes. Educationally, it raises huge ethical flags about AI grading, systemic bias, and lack of transparency. The AI might be failing to recognize linguistic diversity. Explanations are needed to even diagnose this, let alone build trust.
Legally.
Potential breaches of transparency, AI Act Article 13, GDPR's right to explanation, Article 22, lack of meaningful human oversight, Article 14. The bias itself suggests flawed data governance, Article 10. DSA, DGA, Data Act could also be relevant depending on the platform and data flows.
And technically, can XAI help fix this?
Automatic grading is complex. AI needs deep semantic understanding. Post hoc XAI methods like feature relevance analysis, SAP, LIME, PFI, PDP, can help identify what features the AI is focusing on, revealing biases. Maybe it's penalizing certain grammatical patterns unfairly. Bias often stems from training data. Collaboration between developers and educators is crucial to detect and mitigate it.
Challenges and recommendation.
Challenges: ensuring diverse training data, the black box problem, balancing automation and human judgment. Recommendations: stop using the bias system, conduct a stakeholder review, demand transparency from the provider. What's evaluated? How does it correlate with grades? Collaborative problem solving, impact assessments, FRIAs, DPIAs, diversifying data sources, Article 10, accessible explanations via dashboards, Article 13, mandatory human intervention, Article 14, adhering to GDPR principles, minimization, anonymization, consent, preventing dark patterns, DSA, and potential regulator involvement.
These cases really show the practical importance of XAI. Table 8 summarizes responsible AI implementation, transparency, oversight, privacy, fairness, evaluation, appeals, checking bias. It pulls it all together.
It does, and Table 9 focuses on key takeaways and implementation concerns for different stakeholders.
What are the main messages from Table 9?
The need for feedback from educators and learners is critical. Is the AI actually helping? Also, a warning about over-relying on explanations. We need clear use cases demonstrating improved educational outcomes. And then specific focus areas for institutions, developers, policymakers: ethics, transparency, accountability, equity, privacy, collaboration, and professional development.
The report also mentions visual explanations, figures 5 and 6. Why are visuals useful?
They can make complex information much more accessible, especially for non-experts. Pictures, charts, diagrams. Figure 5 shows an e-learning platform using text and graphs for students. Figure 6 shows the SANA tutoring system using radar charts for teachers to visualize score calculations and confidence levels. Visuals can often convey insights more intuitively.
Okay, two more detailed scenarios looking at stakeholder perspectives. First, a primary school using an AI math tutor, ITS, for Emma. High risk under the AI Act. What are the different viewpoints?
For Emma, the student, it's about personalized learning, but also understanding why she's doing certain tasks, feeling engaged, balancing support and independence, and understanding the tech and her teacher's role.
For the teacher.
Assessing effectiveness, trustworthiness, needs human oversight, explanations of the AI's teaching approach, transparency, ensuring integrity, respecting rights, needs a transparency mode maybe, showing data inputs and logic paths, addressing diverse needs,
Educational leader.
ensuring alignment with school goals policies, promoting equity, fostering trust, ensuring compliance, needs explanations of customization, standards alignment, support for mixed abilities, adaptability,
Policymaker.
ensuring transparency, trustworthiness, responsible use overall, needs clear explanations, data privacy security, fair recommendations, accountability, promoting AI literacy.
And the developer.
Creating adaptable, explainable, equitable tools. Transparency by design, bias detection, fairness auditing. Table 10 shows how the XAI dimensions, scope, depth, etc., apply here with examples.
Next scenario. Mrs. Lee, a middle school teacher, using an AI lesson plan generator, OPG, for fractions. Lower risk if no student data is used, but XAI principles still apply. Perspectives.
Students need to trust the plans, know about AI use and data protection, if any, feel lessons are differentiated, and see the teacher as central.
Needs to lead the teacher.
Needs to assess effectiveness, trustworthiness, customization potential, maintain her agency, understand the pedagogical approach behind the suggestion.
Designer developer.
Focus on transparency, explainability, and design, customization for mixed abilities, alignment with standards, bias detection.
Educational leader.
Ensure transparency, explainability, rationale for customization, alignment with goal standards, support for mixed abilities, adaptability to teacher preferences.
Policymaker.
Ensure transparency, equity, responsible use, data privacy, if applicable, fairness, accountability, promoting AI literacy. Table 11 gives examples of XAI dimensions for this LPG case.
And Table 12 neatly summarizes the roles and attention points for all these stakeholders, learners, teachers, leaders, policymakers, developers. It really drives home that this is a shared responsibility.
Absolutely. Section 3.6 emphasizes this human-centered aspect, needing active engagement and ethical participation from everyone. AI literacy is key for both learners and educators, referencing frameworks like DIGCOMP and UNESCO's work. Understanding bias and ethics is crucial.
The final major section digs into the foundations and competences needed for XAI in education. It stresses critical thinking and defines AI literacy.
All right. AI literacy involves using AI effectively, evaluating its accuracy and trustworthiness, and using it ethically. It's crucial for XAI because you need these skills to understand the why, assess the explanations, and question the system. Ethics needs to be baked in, and XAI helps justify decisions ethically.
And it outlines how XAI understanding fits into different education levels.
Yes, from basic understanding, ICED 1 to 3, to application and system design. It lists key competences for technical teachers, understanding XAI techniques, human-centric design, and non-technical teachers, critical literacy, pedagogical integration, plus for AI developers, integrating explainability by design.
Section 4.4 connects the XAI dimension scope, depth, etc. to the mindsets and pedagogical approaches educators need.
Exactly. And Section 4.5 gives concrete examples for different school levels.
Like primary school, ICED 1.
Using simple tools, unplugged activities like games adapted to explain AI choices.
Lower secondary, ICED 2.
Deeper exploration. Projects like investigating recommendation algorithms, assessing bias using frameworks like UNESCO's, using XAI in personalized learning, science models, social studies, case studies, biased AI, even grammar checkers. Fostering a culture of questioning AI.
Upper secondary, IC 3.
Real-world impact analysis, law, healthcare. Analyzing the AI Act for transparency. Studying bias cases, facial recognition, using open-source platforms for simple model building, activities like testing bias versus balance data or combining literature like 1984 with AI art generation and critical evaluation,
And higher education.
differentiating technical versus non-technical degrees, advanced AI literacy for tech students, building, evaluating, deploying ethically, using developing XAI tools. Non-tech focuses on critical application and societal implications. Examples include using Chaplime for social data, medical students training models and assessing accuracy, teacher trainees critically evaluating AI-generated lesson plans for bias.
And Table 13 wraps it up with recommendations for all stakeholders on fostering AI literacy and responsible adoption.
It's a really thorough roadmap.
It definitely is.
Yeah.
So, as we bring this deep dive to a close, what's the single most important takeaway you want people listening to hold on to about explainable AI in education?
I think the core message is this. XAI isn't just some optional extra, some technical add-on. It's absolutely fundamental. It's essential for building trust, for ensuring AI is used ethically, and, frankly, for making sure it's actually effective in supporting learning.
So, understanding how the AI arrives at its decisions is key. It empowers learners, right? Supports educators.
Exactly. And it helps policymakers create sensible rules. It moves us away from just passively accepting AI outputs.
This is crucial in education, where the goal is understanding and critical thinking, not just getting an answer spat out by a machine.
Precisely. And that really leads to the final thought, a question for you, our listener, to maybe ponder.
Okay?
As AI becomes more and more woven into the fabric of our learning environments, how do we collectively ensure that the focus stays firmly on fostering genuine human understanding and critical thinking, rather than letting ourselves simply rely on or accept the automated outputs?
That's a really crucial question to keep asking, a great point to end on. We definitely encourage you to check out the full report from the European Digital Education Hub if you want to explore these ideas further and think about what XAI means for your own context. Thanks for joining us for this deep dive.